president of the NAC. And, yeah, he went for an internship at the Moscow Electrical Engineering Institute. And yeah, so today we'll be talking about matter and antimatter. And yeah, it'll be very good. So we'll talk about it. I think, oh, I just read it on the internet. So, good evening, everyone. Today I will talk about matter and antimatter. What is antimatter and antimatter and matter? And how is it relevant in our universe, in astronomy that we do? So, before understanding what is antimatter, we should understand the physics behind it and what maths we use to index it. So, first we go in maths. Maths is very simplified. So, seniors, please, and juniors, I will try to explain it as best as possible. Okay. So, suppose you have x star. So, there are two roots to this equation, plus one and x. Okay. So, we have two roots. Okay. Now, according to special theorem related, you can write any equation in the form of a quadratic equation. Okay. You must have heard about Einstein equation E equal to mc square. That is an incomplete version. The complete version is for any particle with moving with momentum p. The energy is given by this quadratic equation, which is E square equal to B square C square plus M square to the power M square C to the power. Now, similar to the equation above, we can also take two roots of this equation, which is uh, plus root and minus. But and now you can say that now yes, energy has a positive value and negative value since everything inside the square root is positive. So energy has two values. But there is a problem. The problem is negative values are not physical. Okay. What I mean is, suppose this is the space. This is the space of the universe. There is nothing here except for Shiva. Okay. Only Shiva is in the universe, and he is moving with a velocity with respect to the value. So now Shiva has a positive value p. We define energy with respect to vacuum. Okay. So anything in this universe will have a positive energy with respect to vacuum if we take vacuum energy as zero. Okay. Okay. So hence this negative value doesn't make sense in essence. So negative values can't exist physically. So this approach is wrong. Oh, so what other approach can we take to answer the same question? Then comes a mathematical tool called field theory. What is field? You all have heard about electromagnetic field. So we have in class 12 seen the equation of an alternating electric field equal to E naught sine kx minus omega t. This is a wave equation. Okay, it has this can be complex as well, so it has a phase part as well. E naught not I. So it has a phase as well. Slightly wrong. It has a phase as well. Now, what do you do? So, electric field is not a physical object. You can't see electric field, feel electric field. What you can feel is the effects of electric. So, in this diagram, this is magnetic bar. It has two poles, and you have iron filings around. Now, iron filings, due to the potential, arrange itself around the magnet in this. So we see the effects of magnetic field or here electric field. So how do we calculate these effects? One of the most common quantities related to the electric field is the intensity of the electric. So how do we define electric? intensity. And intensity is just the square of what square of each term. Yes? Okay. So how do we define this? Suppose I have a function f of y, which is y square, mod y square. Okay. Now, if I pass this e here, we'll get e f of e equal to mod e square. So, in a sense, if I operate this function on the value of e, I will get the intensity of the light that I am receiving. And I can measure this value. So, given an inherent information about the field, which is this equation, I can square it, which is applying a function to it, extract useful information from it, here, intensity. Something is similar happens in field theory. So, instead of assuming particles as individual particles, what if we assume them as a field? What I mean by field is, suppose that there is a field of electrons. Uh, there is a field for electrons. There is a field for electrons. And after application of such kind of functions, we generate new electrons or kill old electrons. Understood? Okay, I will explain again. So here, like we had electric field upon operating a square function, we got the intensity. So in an analogy, what we are saying that there is something behind electrons, which is a field, let's say an arbitrary field existing, and we operate certain functions and derive electrons, measure electrons. Okay. So in truth, what we are seeing is the result of a field, not the actual field itself. Effects of a field, not the actual field itself. Just like the electron. Okay. So in the same way, in field theory, we define fields of an object. Here, suppose there is a field of electron, and this field is represented by the object above. Don't think about the object much. So the first term is then analogous to the kinetic energy of the particle. Second part is the potential in which the electron is going through. And the third part represents the interaction between the photon and the electron. And now the green layer is sort of an operator. It operates upon the field and gives you information about the field. Okay. So the field is below. You operate the field, you get bumps up. Yellow bumps here. I have a laser. Yellow bumps here. Okay. These yellow bumps are the actual electrons that you can see. So in a way, this field transforms into, like, gives information about the actual real life electrons. Okay. So if we take this approach, where we reach, okay. Now we come back to this problem. We come to here, which we had a quadratic equation. Take this, we can decompose this in another form. This form. I will explain to you what this is. People who have taken special field relativity must have seen this. E mu, E upper index mu, is defined as E by C and other components of the momentum. Okay, so this is a vector which has four components instead of three. The first component is the energy, and the second components are the or other three components are the components of the momentum. Okay. Now there is a lower index object as well. This one. How I define this is P lower index mu is E by C and minus P. I define it like this. I can construct things. I'm constructing things randomly. Okay. I define it like this. This is just a mathematical construct. Okay. Now I take a dot product of them. What I will. dot p mu. When you do calculations, you will get minus e by c square, c square by c square minus e square. Okay, you will get this. When you will put that there is a c square missing there, sorry. So when you will put that there, you will get the original equation back. Okay, so we can write this thing in the form of a four four vector representation. Okay, we can write this. This is just mathematics. Just I'm defining this. Nothing physical about it. So anything physical about it here. So, yeah. So now, in field theory, we have a similar object as this, which is, I'm not going through how we get this equation. In field theory, when we go from particles to field, we have an inherent field of the particle. The del square acting, this is the partial derivative. Del square acting on phi gives you something similar to this four momentum object. And S gives you the mass. Okay. So something similar we see in the field. Now, what if we decompose this? We can decompose this in the form of matrices. Everybody knows matrices. So A is a 4 cross 4 matrix, B is a 4 cross 4 matrix. When I multiply this and eliminate all the terms, I will get something similar to this in with an identity term, the joint term. Okay. So this is a valid decomposition that I can do. Now, Paul Dirac saw this and was inspired from this. We knew everything about this. We get this from something similar to this. Like we get people were inspired in field theory from this and they got this. Now, Parrot this and he generated something which looks like this. Okay. Now, this is an equation which is called as Dirac equation. It is a field equation which gives us the field of particles that is present, the same field that I just talked. Now, if you act this, if you operate different operators on this field, you will get different information about the physical information behind it. But the thing is, all of this that I said, all of what I said is just mathematics. We don't have any proof of this. One more point. This equation provides the hint of existence of two particles. Okay? It tells us about existence of two oppositely charged particles. So if I have a particle of plus q, there is a possibility of existence of another particle as minus q. Just like the case of plus minus the one that we do. When we solve this equation, we get this as solutions. The second point is since this fact say the mass and the energy of both the particles constructed is same. So it solves the negative energy problem. So we get positive mass, positive value particles with different charges, plus and minus. Paul Dirac got this equation, hence it was predicted that there are two kinds of particles in existence. So, do we see those particles? The answer is yes. We see a lot from up till 200 years or something, sorry, 100 years or something. We have discovered and detected a lot of particles. The first particle was detected was positron. It was detected by Gauss experiment by Carl Anderson, and this. So you see this trail. You see this trail. Okay. So everybody knows the right hand rule. So B cross B gives like in a constant magnetic field deflects the particle. So since it is a positively charged particle, it will deflect towards the left if the field is towards in downward direction. Okay. So field if applied downward direction, this particle we saw deflected left. When measured the charge to mass ratio, it was same as the electron, and hence it was concluded that this was a new particle, and hence it was named positron because it had properties opposite to electrons. This was detected from cosmic rays coming from August. So yeah. Now we discovered these the discovery of these particles proved that the mathematical construct that we constructed is robust, and yes, there exist antimatter particles in universe. Okay, so now QFT came like blew up. So now it went into usage in condensed matter physics, high energy physics, medical imaging as well, and cosmology. This is related to my talk. Condensed matter physics, you can construct lattices and go and very far and use the same principles to consider them as fields and solve for them. High energy physics, there are a lot of detectors which from the principles derived using field theory, they predict the properties of new particles that are generated from collisions. And medical imaging, this is new, which I didn't know. You can use beta decay to map out rays. So positrons made by the beta decay can hit the electron membrane and give out energy, which is mapped. So this is called a PET scan, PET scan. So people use this to scan the rays and detect any problems. So what is what all this is like? How all this is related to cosmology? So remember I told you that the particles are symmetrical in nature. The equation that I showed is symmetrical in nature. So we have two types of particle with just opposite charge, but everything else should be the same. All properties should be the same. But if that is true, where is everything? Why don't we see antimatter people around us? Why don't we collide with them and explode? So that is a very big question, which is called as baryon asymmetry problem. Uh, People know about like what is the meaning of baryon? Baryon is collectively the collection of matter and antimatter. Okay, both of them collectively are called baryons. So if it is symmetric, where are they? So current observational estimates have estimated that there is only balance of 1 billion in the number of matter and antimatter particles. So this is a huge difference, and we don't have a solid theory about it. That's why this difference exists. Now, whatever I told you, the symmetric nature of the antimatter and matter, that is slightly correct. Modern theories and modern experiments have shown that there are certain differences in the properties of matter and antimatter particles. What are those? Uh, the three primary source of differences are charge, parity, and time symmetry. So here's one more diagram. Suppose you have a mirror. So you see yourself in the mirror and you see a mirror image of yourself. You wave your right hand, it will wave a left hand. But you know that it will wave a left hand because that is the property of mirror. But in quantum physics, in these subatomic particles, when you place them in front of some kind of mirrors, some kind of functions, mirrors, those properties are not symmetric in nature. Those properties change. So, for example, neutrino, when undergoes parity transformation, should change to opposite. So I will explain this. So what is parallel transformation? Suppose you this is an x-axis, this is a road. You are standing here, and you have a neutrino. You are observing a neutrino coming from it. Now you notice that it is spinning in clockwise direction. Okay. Suppose the same neutrino is coming from this side. So you will see it rotating in anti-clockwise. But that is not the case. It is not. No observation has been made that such transformation is true or not. Same case for charge conversion. Charge conversion is just if you have a matter particle with charge q, electric charge as E. Charge transformation is just considering ions. So charge transformation, we have positron. Under charge transformation, it gives electrons. So in some cases, not specifically this, charge transformation is not allowed. So we see differences in fundamental differences in properties of matter and antimatter particles. Okay. So why is this relevant? On small scale, it is true, but on large scales, they can cause a huge problems. So what are the problems? I will come to that in a bit. But suppose we will start making our universe, which has both matter and antimatter particles. So at the start, there was a big soup which had a lot of subatomic particles, which particles that consist of that protons and neutrons are made of, quarks and gluons and stuff. So this soup, when this is the theoretical prediction, but this soup, if undergoes phase transition, condensed form atoms, antimatter atoms and stuff. Okay, this is under debate, but still. Suppose there is a process which converts this soup to matter. Okay. Now, if that is true, so suppose the antimatter and matter particles are formed like this. Thus, dots are matter particles and circles are antimatter particles. So, if I have an area filled with this, they will interact with each other. They will annihilate each other. So, we expect them to finish each other off and nothing remains. Okay, so that is a problem. Suppose we have an extra matter particle in it. That will solve the problem, you think. Or we think that it will solve the problem. So charge and parity invariance requires that this difference in the number, we can't have matter particles infinitely larger than antimatter. That will violate physics. So conserving that, we say that there are slightly 1 to maybe 5 more matter particles than antimatter. When we do the calculations, what we find is that upon up till the modern age, if all these calculations run, there is a huge difference. The number of particles that form is 10 is from minus 70. So, like n gamma is the number of photons in the universe. So, with respect to the number of photons in the universe, the number of particles and number of antiparticles which form is from minus 70. Okay? But the current observational estimates of the universe puts us at 10 to the minus 9. So there is approximately an 8 order difference in both the values. So whatever we constructed up till here is incorrect. There is something wrong. Okay. So what is the workaround from this? Whatever we constructed is wrong. So suppose we consider the asymmetry, the second thing, the excess of atoms, excess of bariums, with slight modification. What is the modification? We consider them as bubbles. Okay. What are bubbles? I will explain about these bubbles in the following slides. Uh, how to blow bubbles. So calculations have shown that if I have just so what this theorizes, these bubbles theorizes, this theory theorizes, is that suppose instead of matter and antimatter particles forming inside in a mixture, we have matter and antimatter particles forming in exclusive regions. How these forms is still under research, but we theorize that there are exclusive regions consisting of matter particles and antimatter particles. Okay, understood? So these regions, if they are 10 micrometer in size, 10 micrometer in size, when these matter and antimatter particles form, if these regions are of this size, then they can develop to form large structures in universe. Large structures in universe of approximate size of 10 to 11 solar masses. How? there will be annihilations between matter and antimatter particles. Okay, these annihilations release energy and push the particles, the existing particles which are towards the center of these regions together, like closer to the center. So it forms an exclusion region between both the laws. Okay. So this kind of construct calls these regions of antimatter domains. Why antimatter domains and not matter domains? Because we have assumed that the matter is more than antimatter. So we assume that just like the bubbles that I showed, it is in water bubbles of oil are present. So something like that. So we have bubbles inside of themselves regions surrounded by matter, and these are separated by regions of exclusion regions of annihilation. Okay. As the time moves on and the universe cools down, these regions move farther away from each other because of dark matter. Uh, One more, antimatter is different from dark matter. So due to dark matter, these regions come together, they coalesce. One more point, if antimatter regions come together, they will just shut because there is no annihilation between them. Okay. So I can have multiple small regions of antimatter of this much size. Upon time relation, we can form a large region of it. The theory predicts this. Okay. So upon calculations, we see that the mass of these regions can reach 10 to the power 11 solar masses, which is huge, which is the scale of galaxies. So any questions you can ask me, stop me and ask. Yeah. How did how did you theorize this theory? Thank you. So yeah, how did theorists theorize this theory? So I told you about the anti-magnetism. So so the so yeah so the so this was thought upon using an analogy. The regions of star formation. Okay, regions of star formation are conserved. They are small and they are excluded from other regions. Okay, so they have their own self gravity as well as they have exterior regions separated out from each other. They also have magnetic fields which acts as a shield around them. So what people thought, this is a very simplified version, but what we thought that these annihilation has positive. So suppose yeah. So pressure, the pressure is acting towards the inside, forcing them towards this end. So, okay. Better example would be surface tension. Yeah. Better example would be surface tension. So, you have water, you have oil droplets. Okay. Oil droplets form spherical droplets inside the beads. Why? Because there is a difference in the nature. They don't mix together and they form exclusive regions because only form spherical regions because of surface. So, seeing similar to this analogy, instead of having surface tension, I have annihilation, like pressure due to the annihilation. So, lot of annihilations are happening. They are blowing things apart and forming an exclusive region surrounding these bubbles. Okay. Now, if these bubbles are large enough and if you give enough time, these regions can develop to those sizes. Calculation are still. Okay. So these are of galaxy scales and they can form galaxies. Okay. What is this? Can anybody tell me? Beautiful. Cloud. So this is a very recent survey of H alpha region, which is surrounded by a dark matter halo. So suppose it is surrounded by a dark matter halo. It does not contain any stars. So it is the first gaseous region that we have observed, which does not contain stars but just gas, and it's bounded by dark matter. So so now we are building our universe. So building our universe based upon this bubble structure. Okay. So now these dark matters have enough strength to pull all the matter together. Okay. So the annihilation will gradually slow down. Why? because all the matter is condensing to certain points. So you must have seen that chain-like structure of the what do you call it? Forgot it. Network type structure of superclusters and network it's simulation you see in simulations filaments. So filaments have certain bright areas in them. And why do these bright areas exist? Because the dark matter presence of dark matter is high in those regions, and everything come together and they exist there. So because of gravity and dark gravity due to dark matter, the regions becomes more and more exclusive, and the annihilations become less and less frequent. So taking all of that in consideration, we can say that these regions become exclusive enough to host star formation or host evolution without internal other matter with the danger that it will annihilate everything. Okay, so we are constructing our universe. We start with 3,000 years ago with a temperature of 1,000 Kelvin. The oh okay, I forgot. So we have a gas giant. Now, what does this gas cloud have? It has a temperature, it has a pressure, and it has a volume. What are these quantities? These are thermodynamic quantities. Okay. The problem is in this statement is we don't know whether the same law of thermodynamics applies for antimatter or not. Okay. So there are two schools of thought. One believes that yes, it applies. One believes that yes, no, it does not apply. The evolution of antimatter, the what does the second law of thermodynamics says? Entropy of the universe is always increasing. Okay. The other school of thought says no, the entropy of the universe for antimatter is decreasing. This results in measurements of negative temperature, but we will not consider that. This is just an idea that I am giving it to you. You have doubts and you can ask me later. But so we will only consider CP invariant school, which considers that for matter and antimatter, temperature is increasing, so entropy is increasing, and us observer will measure temperature for both antimatter and matter same. So now we go to star formation. Star formation is a very cool process. So you have dark clouds, they condense. What is CPT? CPT. So the invariant the transformation that I showed you. So if you apply certain transformation, certain combination. So if you apply time transformation first, parity transformation first, and charge transformation next in order, it is see that the circle is theorized. The matter and antimatter are linked. So the if you place this mirror made out of CPT, the properties of both antimatter and matter will be same. No? But this is only theory. The other school of thought says no. If you place a CP mirror, then only the matter and antimatter will be same. If you add T here, the properties will change. There are two schools of thought debating each other. So yeah. So yeah. So we will move here. Any doubts? We will stop. So so how do matter star form, or in our case, thermodynamics is same. How do antimatter star will form? So our antimatter star in the other region, we have this dark cloud. In it, we have clouds of gases. The gravity from these clouds and the gas, the surrounding gas, pulls everything at the center. Since it is increasing, like the volume is decreasing, the pressure will increase. Okay? Considering the gas isotherm. Okay? PV equal to NR. PV equal to first. Considering the gas isotherm, the temperature, pressure, volume will decrease, pressure will increase. So the central region start resisting the infall of gas, infall of the material, but that will heat stuff up. So the temperature at the core gradually rises. Okay? It rises to a point that it starts burning, not nuclear fusion burning, but still like it starts to release a lot of energy. Okay, it heats up. Now, as you increase the density, uh, the core becomes translucent or opaque. Understand? So, if you have a lot of gas falling, if you have a lot of gas falling, lot of gas will block the light here. Okay. If more light is blocked, the center region becomes hotter and hotter, and it becomes so hot that nuclear burning starts happening. Once the nuclear burning starts to happen, it can form a star. Okay, clear? So the construction that we were doing, the temperature being 1000 degrees and the age of the universe as 300 degrees, if you will follow the same process, it is predicted that stars of mass 40 solar masses can. Okay. Note that we are starting from a hydrogen gas cloud, or in our case, anti-hydrogen gas cloud. Okay. So the gas that is present is only hydrogen or helium. Sorry, only hydrogen. Only hydrogen. Hydrogen atom. So there are some difference in the properties of the gases, which causes the stars to be so massive. Okay. So it is predicted that 40 solar masses of star 40 solar masses stars can form with a lower bound of 22 solar masses. So we will have at least this big stars in early coming in early given our initial condition. Okay. So, but the existence of such massive stars even for matter is still under question. So theory says yes, these can form. Theory says very so, but we don't have observational data yet. So this is a model which was done by great scientist Yoshida. He does stellar evolution in early universe for matter systems, and he gave this chart which has modern stars, not actual data stars, modern stars. And he puts that if the evolution of early universe happens in the same manner as antimatter that we discussed, this will be the distribution of the first generation of stars. Okay. And the above stars that you see, these four stars, are the observed biggest stars in our universe. Okay. The biggest star being 120 solar, 500 solar masses. Okay. So observationally we are constrained, but theory says yes, it is possible for both matter and both antimatter. Okay. Now, the only caveat in our theory is that first, the thermodynamics can happen in similar manner that antimatter and matter has same thermodynamics happening. Second, whether anti-hydrogen fusion reactions happen or not. So we know that in the center of the stars, nuclear reactions are happening. But do we know that those nuclear reactions are happening for anti-hydrogen atoms as well? We don't. A lot of people are doing the research in lot many different ways, but this is still a very hot topic in this field. If anybody wants to explore, they are there. So yeah. So so this is just a scale. If this kind of this is the mass of the star, this is the type of kaboom that will happen. Okay. So now conclusion. See how do we detect these antimatter stars? Okay. So seeing those stars is kind of difficult. I will first go through the so the readily detectable quantities that we have. It has gamma ray, which is we have specific spikes in gamma ray spectrum, which comes due to matter and antimatter annihilation. So if we have annihilation between two regions of matter and antimatter, say two matter and antimatter stars are colliding and annihilating each other, we will have a sharp spectrum from them. But till date, we have not received any gamma rays which match with that spectrum. The other is transitions happening in certain exotic species such as proton, antiproton, so H2 molecule, but having a proton and an antiproton. So it has theoretically predicted, but we have not got any spectrum from it, or proton and helium. So these species are predicted, and we expect spectrum from that, but we have not received spectrum from that yet. Another possible set of detection ways are the ones below. Note that these are still underway. Some of these missions are under being built. They are under process. They are in the initial testing phases. For gamma rays and X-rays, we have Chandra, Space Observatory, King James Webb. So for these possible detections, we have the AMS2 alpha uh, magnetic spectrometer on ISIS-2, which measures the antimatter flux coming from the outer space. But it has been able to detect only one atom of anti-helium till date from outer space. We know supernova forms heavier atoms. So if this detector detects those heavy atoms, we are sure to say that yes, those antimatter stars are possible. But there is a limitation to this because it has a finite sensitivity. It can only detect up to anti. Okay, so we are technologically inferior to detect those stars. If those stars exist, yes, it is very much possible. But but still, everything is on paper. Everything is theoretical. Uh, all these calculations are made to show what would be the influx, what will be the possible values of detector, what should it detect so that we can detect. So yes, thank you.